Hi everyone, my name is Mishurenko. I'm a game designer, VR developer at Synesthetic Echo. We're in New York. We're a tiny studio focused on VR design and development. You can follow me on Twitter at MAR Mishurenko. And if you have any questions at all, please engage, send me a message, and I'll be happy to answer. So today we're gonna be talking about how Houdini can improve VR game development workflows based on the example of my game, Bizarre Barber. So what is Bizarre Barber? Let's see. So Bizarre Barber is a VR game. It was funded by Oculus and subsequently funded by NYU Game Center. In this game, you play as a barber. In the underground, you cut hair of like little people or mutants. You earn money, you battle bosses, and it's a simple and fun and very embodied action game. Yeah, as you can see, you have different scissor mechanics. Your scissors can be sabers, swords, and other stuff. So we had 14 months to develop the game from start to finish with a 3-person team. Indeed, we were lucky to have funding, but the funding was tight and we didn't have any specific art person in the team. So we kinda had to wear multiple hats. And that's why we decided to employ Houdini, employ it heavily to save some time and money on VR development. So this is the whole list of things that we made with Houdini. Starting with creating character generator, we connected MIDI interface to our generator. The game is about hair, so obviously grooming setup is important, and we did it all with Houdini. We wrote some custom asset exporters and importers. We learned how to do seamless in VR editing process based on the example of our level design. We used GAMEDEV tools heavily. We created a tool for marketing assets, and we also used Karma. It wasn't beta version, but we've been able to use it just fine. So let's start with characters. So in our game, we have about 13 levels, and so we decided to make every characters very different and very distinct. Characters are hard on indie budget. This is our actual character concept art on the left. We had to go through all this pipeline, starting with concept art, through sculpting, cleaning, unwrapping, texturing, rigging, grooming, animation, and finally programming in Unity. Plus added constraints for VR. VR is very resource heavy, so we had to optimize the characters heavily. So that was our initial math in our game design document. We wanted them all to be different and fun. Luckily, we only had heads to make, heads and necks, no bodies, no rigs. But we still needed 40-50 mutants per level, and 10-12 birds, and 7 custom bosses, and the end of each world, and some custom animals. And overall, we decided to have 13 levels, and that's about 1988 total characters. Insane. But is it? Because with procedural generation, everything is easier and cooler, so we decided to employ it. We decided to make a generator that generates tons of characters, and then, we can just import them into the game and enjoy tons of time that we saved. So this is our concept art process. This is our concept art process. We started very traditionally doodling on paper. Then we made some more doodles in VR to define some shapes and colors and overall mood for the characters. Then we started to create first doodles in Houdini just by combining primitives and trying to make like very simple manual combining generator. That was our first sketches in Houdini. So yeah, we made a thing that makes things. In our case, it's a head maker. So you see here is our structure, our node structure for the head, and on the right is the nose. As you can see, we used a little bit of attribute wrangles just to write some custom tools for modeling. But mostly we used just Houdini built-in tools, and we only used custom Python nodes and more attribute wrangles in the very end when we had to make exporters. So this is our first test results, manual generation, different colors, fun folks. Seems to be working, yay! We had to set up some rules for the mutants, just because we had some, sense of art direction for them. So they all should have one or more eye, 2 ears, eyebrows, nose. We thought we'll make them mouths and probably eyes with like animating capabilities, because we plan to add animation and blend shapes further down the road. They will have accessories, in our case glasses and mustaches, and also 8 procedural styles for hair, with the parameters for hair count, length, and distribution. We decided to simplify our life by not having the textures, because textures means unwrapping, and so in Houdini it's easy, but it's still hard, because you will have this texture overhead in VR, so we decided to just not use them and just use vertex colors and fun shaders in Unity. Speaking of Unity, so this is our rules for Unity, for the game engine. We didn't use Unity Houdini engine, we just decided to add some custom importers, because we needed very specific workflow and very fast. And so here you can see our characters are being imported and automatically added colliders, materials, hair are generated in real time. We're setting up shaders for hair and also for the meshes. We generate thumbnails for them, because we'll need them later to use in the level editor. We also add in physics and joints, because we don't have any animation for it. We also add in necks, and all of this has the ability to be corrected and iterated without exiting VR mode. Yes, you heard it correctly. If we have some character who has like too much hair or too little hair, we can go in Houdini without exiting VR mode. In Oculus, you have this Oculus Dash panel, and you can just open Houdini, and Houdini is friendly enough so you can actually change some parameters from VR and then re-export it to Unity. That tremendously sped up all our workflows. So we used quite a lot of Vex, but we also used Python for creating some custom rules for how our characters should use how their body parts should adhere to the head geometry. Here on the right you can see the example of our custom edge loop. We also did some fun stuff with Python. For example, this one is an automated color selection tool. Sometimes you have to look for this beautiful palettes, and you have to discuss your color choices with your art director. We didn't have any of this. We didn't even have an art director. So we just read some color theory, and there are complementary colors and different models of how they complement each other, like hex, stride, custom. So we use Python for making this funny little tool that automatically finds best colors, complementary colors, and adds vertex color on our characters. You can iterate through them, you can make seeds, or you can just manually select whatever you like, and it also has value and saturation variables, so you can make them pop, or you can make them really light. Alright, so we did all of this, and then we were ready for the big day, the generation day. So we set up the generator, and we set up all the pipeline, and now we just had to press this one button and generate 1,000 of characters. So here you can see our attempts to generate 1,000 of characters and also my reaction in real time. Okay, as you can see, so we kind of set up the parameters max and mins, but it's still strange because there was so much garbage. I mean, there were some pretty nice characters, but they're also all kind of like computerish. There was almost no human touch on them. So as you can imagine, it was failure. And yeah, later, probably like 3 or 4 weeks ago, I stumbled upon this wonderful article from Daniel Davis about how all generative design is doomed to fail, about how inefficient it is. And I wish I had this sooner, so please go and read this article, it's amazing. Here are some takeaways. So quantity doesn't substitute for quality. We indeed were able to generate thousands of characters, but then comparing these options and sifting through this garbage was really, really boring. And I felt I became a curator instead of an artist, and curator is a very different job from artist. Artists create, while curators, I mean in this case, they kind of erase all the junk and garbage. And this is the opposite of creation, and it was not fun to delete many of the failed versions. So I can justify the time spent working on generator because we ramp up, our Houdini skills and Vex skills and Python skills. But then eventually I cannot justify the time sifting through the garbage. It was very painful. I would never do this again, and we decided to work through the generator and fix some, wrong decisions that we made. So we started with putting it fully into manual mode. So here on the right you see our asset for generation. It's now all manual, so you have this little head, eyebrow, ears, nose, wherever interface, and you just do it one by one with a very clear artistic intention now. As you can see, we're using the systems of takes here, so after you generated something decent, you can kind of crossbreed them together. You can have children and grandchildren, and honestly, take system in Houdini is amazing. I'm not sure if it should be used for this purpose, but it was very helpful for us. We may make, we've been working on this file together, and then if any one of us made some great character and the other person also made a great character, then we can breed them and make the third character their child, who is even better. It was slower than procedural generation, slower than automatic generation, but it was more flexible and it was still very fast comparing to the manual modeling. It was about maybe 3 minutes or top 5 minutes per character. But we still thought to improve the speed of the generation, so the next step was to reduce some character density, so we decided to reuse them. And that was really good decision gameplay-wise, because players seems to like meeting familiar faces, so they like repeating patterns, and it was absolutely alright to reuse some characters for us, and even some objects. It was totally cool, and players were looking forward to see familiar faces. So we also decided to engage the community, because we noticed that even with the manual generation, it was only 3 of us doing this. And our characters started to look suspiciously similar to each other. And I realized that we are all biased, we're human beings, and everyone is trying to make a character that looks like them, so I was mostly making woman, female, kinda female characters. And my colleagues were making characters that also look like them and have mustaches, for example, as my partner has mustaches. So we decided to engage NYU Game Center community into the tool design and also into the generation. That was a really cool real-life test for Houdini, because none of them are 3D artists or even opened Houdini before. So what we did, we just asked them to sit in front of the generator and just play with it. And of course that took a little bit more time than us, because they had to learn how to use the viewport and stuff like that. But eventually they were able to generate characters, and then they started to complain that they missed this and that feature, that they want, for example, glasses to be shaped like hearts. And we very quickly tried to add these changes into our generator asset. And eventually it paid off, because we have such a great diverse community at NYU, and since everyone was trying to make characters that look like them, we ended up having a bunch of really cool and different characters. And also, that was my personal kind of idea. We only hired voice actors with different accents, so our characters all have different accents too. So the next step for fixing our mistakes with character generator was adding MIDI. So MIDI is actually very, very cool. So look at this. This is our bird generator and our $30 Cork MIDI controller. You can still buy it. They are very cheap, they're very sturdy, and you can map like about 100, even more different parameters. I mean, we didn't need that much. But even with like 12 or 15 mapped parameters, the generation process became such a fun activity. You can actually design crazy things that you could never do either with fully procedural automated generation, or with like manually with mouse trying to move those sliders in Houdini. So it's a very embodied process. It looks very similar to like playing music or something like that. You can also apply this for animation, for faces. And another great thing is that you can work on the same character together. That was really life-changing for us. We had so much fun generating those guys, and if I ever want to actually make some blend shape animation, this is our chance to do it. So the worst part of setting up the MIDI was to actually properly selecting the minimum and maximum for each parameter. But once we did that, everything else is just like a breeze. And again, Houdini has really great interface for setting up MIDI. We also, like in other experiments, we connected lip motion to Houdini and kind of tried to create the characters with just like hand wielding, but that was a pure experiment. It was a little bit harder than just connecting MIDI, but still possible. So if you want to learn more about this, please hit me up. I will tell you. This is our generated birds, MIDI generated birds. Look at them, how awesome they are, very cute. Okay, so this is another thing that's really great for Houdini. It's this whole optimizing geometry process. So we needed a real-time crowd simulation, and by crowd I mean like our weird and bizarre crowd of head characters. So here you can see we used Unity VFX graph and Houdini, so you can actually meet every character that you so this is every character you met during the game, in the end of the game, on the big arena. This is 2,000 of characters, and here you can see they're all cheering at you. So when you do like a great cut, they're cheering at you, and you can see them all around. And it was like really easy and super cool to set up. We just like optimized the geometry and rebaked their vertex colors back to this geometry. Yeah, I think we still have like a lot of overhead in Unity, and we can easily add like 6,000 characters without a performance drop. So we use this vertex animation texture shader really successfully, so we decided to make this fancy little scales for hair, so you can kind of like visually see how much hair you cut during the level, and also see this 1 star or 3 stars or 2 stars, so you can have like a little reward at the end of the level. Yeah, so we just used Vellum for that, and we simulated these noodles in Houdini, and then we set up a vertex animation shader in Unity. I think it was soft bodies for this one. And it works like a charm. It's just one draw call in Unity, and it looks fun. It's a little bit like flat lighted, but for our purposes it's alright. Yeah, I cannot imagine like how much time we'll need to set up like this level of quality manually in Unity. So imagine all the individual strands, all this like it would be like nightmare. And like these noodles took us maybe 1 day to make and then import to Unity, and then just have this visual effect in there. Grooming, of course, so it's a game about hair, so grooming is important. Grooming in Houdini is a breeze. As you can see, we're just like applying some simple forces to our hair, and then we're doing simulation, so we can actually pick every frame of the simulation, so all our haircuts, hairstyles are a little bit different, so there is not a single haircut that is like the same as other. All of them are different. You can pick a frame and then export these hair guides into JSON file, and then Unity reads this JSON file and generates hair along them and applies a geometry shader after that. This is how it works. As you can see, we have different hair length and distribution and styles. Yeah, the best part is all the hair are also generating as one draw call in Unity, so we don't have like any overhead on hair. And you can be really creative with this hair. As I mentioned, we had 8 procedurals grooming styles. We even used this hair engine trademarked for our marketing purposes. We can totally add the font geometry instead of the hair geometry and still make it fun and available to cut. In fact, we even have credits in this genre, in this style, so you can cut them. Alright, so the game is done, and now we have to make some graphic design. We have to make some social media assets, we have to make some posters, we have to make t-shirts, you know, all this stuff that's like very useful for the game marketing. So we decided to approach this a little bit creatively. So here you can see the video on how we designed one of our key graphics. Also in Houdini, so we used the real-time simulation for our poster because we needed it to be like very flexible in terms of ratios and colors and stuff like that. You know, iteration in graphic design is also really important. So here you see Photoshop, but actually in the further version of that we stopped using Photoshop and we just use Houdini for everything. So the best part now is that the scissors also are procedural, so you can choose different angle of the scissors and it will generate different aspect ratio pictures. You know, you can do squares for Instagram, you can do like 16:9 for TVs and stuff like that. So this is one of the actual posters about our tournaments, and I'm also wearing this t-shirt, which is made with this asset. It was really helpful, and also don't forget that Houdini has a powerful graphic engine inside, compositing engine, and you can employ that for using all your like graphic work and pixel work, and it's amazing how useful and cool is that. We also created key art with Houdini. We started very traditionally by just doing some sketches on paper and then in Procreate on iPad. And then we did the 3D sketch in Houdini. So we basically reused some geometry from the game. Obviously we had to fake the hair because the hair don't exist anywhere outside Unity, so we had to fake it, but this is the only thing that we faked. The rest of it is just our actual game geometry and some of Houdini's special effects, such as smoke and blooms, and this is final result rendered with Karma. So one of the requirements from one of the VR stores, Oculus store, is having key art at 6,000 pixels wide. So as you can imagine, it's a pretty tiresome rendering job. But Karma only took 40 minutes to render 6,000 pixels on our very small and very weak laptop. We basically have this like beginner level laptop with 1060 NVIDIA GPU. And it still was just 40 minutes. And the only post-processing you can see on this key art is actually adding some denoise in another app, because with denoiser it probably would be like 2 hours instead of 40 minutes. So that's it. So if we had like a little more powerful computer, we probably just used Houdini and Karma for everything. Karma is awesome. As you can see, we've been able to set up custom like highlights and reflections and set up our lighting very precisely and very quickly. So this whole process of creation key art maybe took us like 2 days or 3 days, like at the maximum, which is like very cool result. Imagine in any other software we wouldn't be able to do this that fast and to actually go through this look and feel phase really quickly. So that was all for today. Thank you so much for listening to me. Buy my game. If you have VR, play it. I'll appreciate that. And if you don't have VR, you can support us by buying our soundtrack. This is our website, and welcome any questions. I'll be happy to answer. Thank you.